Okay, so before we start talking about Faust, I just want to point you to two important references. So there is this web page that you probably already visited to install the different softwares required for the workshop. And it's this URL here. Well, you should have seen that. If you didn't see this page, it means that you didn't install the softwares and that you should do it. Trying to, yeah, there we go. Okay, so this web page is pretty important because every night after the workshop, I will just post the code that we studied during the day, so that if you want to study even more at night after the workshop, you can just go here, and look at what we did. And this web page will just remain, it will stay here hopefully forever. So if you go back in 2 years, it should still be here, maybe in 20 years too, or hopefully in 20 years. So yeah. So that's one important link. The other important link that you want to check is also this page here. So if you go on the CCRMA website, and if you just say ~JOS, JOS is Julius Orion Smith. He's the signal processing professor here at CCRMA. So if you go on his website, there are 4 online books that you can access, and those online books are very interesting. So if you want to go further with what we studied during the workshop, you should just read them. Like during the workshop, we're not gonna do a lot of maths. Basically, we're gonna try to get like a very intuitive understanding of the different algorithms that we will study, but we're not gonna do a lot of maths. And I'm just doing that because I know that some of you might not have the background for that. So we're gonna try to avoid maths as much as we can. However, if you love maths and you want to do a lot of maths, you should read those books because they will give you like the mathematical background behind all the things that we're going to do during the workshop. It's a lot of readings. I mean, like the 4 books together is probably like 1,500 pages, so it's a very, very big reference. And, yes.
The other CCRMA, Gareth Loy has 2 books, Mathematics, which is probably a little easier to follow if one is not very mathematically inclined.
That's true.
Yeah.
No, you're right. The thing is.
So those are very thorough.
Those really start from the bottom down, though. Like if you read the first book, it's probably going to be a little bit boring in a way because you don't really do anything. But if you have like high school maths background, you should totally be able to understand that. And it's just that I'd say it's probably more spread. Yeah, it's probably more. Yeah.
What is the other book, please, that you mentioned?
Gareth Loy, L-O-Y. Mathematics, and the second volume in particular deals with Fourier transforms and that kind of stuff. And he explains it beautifully. It's great.
Yeah, there are.
He's also from CCRMA.
Yeah, there are a bunch of books that are like probably higher level than this one. I mean, one of them is a little bit outdated, but it's still very good. I think it's the computer music tutorial by Curtis Rhodes, and that one is very good. It's from 1996, so it's a little bit old, but it's still very good. So yes.
Oh, I'm sorry. The username and password.
Oh yeah, sure. So first, what is Faust? It's a pretty big and important question to answer. But so Faust is a functional programming language for real-time signal processing. And I insist on the fact that it's functional because it's pretty uncommon for signal processing to do functional programming languages. So there are different families of programming languages, and C++, MATLAB, Java, Python, all those programming languages are part of the same family and are called imperative programming languages. Faust is different. So it means that if you already have a background in signal processing and you've done a lot of signal processing in C++, going to Faust might be a little bit traumatizing at the beginning because it is a functional programming language. The thing is, it's not a bad thing because signal processing, especially the kind of signal processing that we're going to do here, where we deal with signals as streams, basically, functional programming is actually easier to understand than imperative programming languages for that matter. So what Faust does is that it generates C++ code. So Faust is it working or? Perfect. So Faust is Faust generates C++ code. So Faust is at a level above C++, basically. So it's just a simpler way to write algorithms for signal processing than in C++. You can use C++ if you want. It's just that C++ is more complicated for signal processing because it's it's less adapted to signal processing than programming languages like Faust. So if I just draw a simple chart, I'm just gonna mute the video for now. But so if I had to put programming languages on the board here, let's say that okay, I'm going to start with Super Collider, for example, because I know that some of you here took the Super Collider workshop. Okay. So this thing here is basically a scale where at the top you have the user, okay, so it's the high level, and at the bottom you have the hardware, which is your computer. And so programming languages can be ordered like that, so very high level programming languages will be closer to the user and lower level programming languages will be closer to the hardware. So at the very bottom here, we have programming languages like assembly, for example, that are very close to the hardware. And here we have programming languages like, I don't know, let's say Max MSP, which can be considered as a programming languages, I guess, or PD or things like that. So those programming languages are graphical programming languages, so they are more user-friendly and they are closer to the user than to the hardware. Okay, so Super Collider, I guess Chuck. Super Collider and Chuck are lower level because they are script-based programming languages. So you can consider that they are closer to the hardware than Max MSP and PD. And those programming languages are specifically targeted towards music technology and just generating sounds and things like that. At a level below that, we have programming languages like C Sound. I mean, C Sound is probably very close to Super Collider, but it's probably a little bit lower level in some ways. At the level below that, we have programming languages like C++, Java. Actually, Java is probably a little bit above C++. Okay, Python. And so all the standard programming languages, and those are even lower than that, but they are still higher in terms of level than assembly, even though C++ is kind of getting closer. And then somewhere in between here and here, well, you have Faust. So the goal of Faust is not to replace things like Super Collider or Chuck or C Sound, but the goal of Faust is to provide you with a tool that is in between those programming languages. So what we're going to do with Faust is that we're not going to do what we do in Super Collider or in Chuck or in C Sound, but we're going to build objects for these programming languages. So let's say that you want to build your own Max MSP external. we can do that in Faust. You want to build your own PD external, we can do that in Faust. Same for Super Collider, same for Chuck, same for CCL. So with Faust, we're going to build tools for those programming languages without having to deal with Java, Python, C++, or lower level programming languages. Okay? And we can also make plugins, which is the other thing we're going to do. So in the frame of the workshop, we're going to do VST plugins. We're going to do audio units, LV2 for Linux users. The thing is, one thing I just want to mention, we're not going to spend a lot of time looking at how to build a user interface in a very clean way, or because that we would need like a month if we really wanted to do things like that. So during the workshop, we're really going to focus on building the audio part of the plugin, but not the user interface. So, but then if you want to build your own user interface, you're absolutely free to do it, and Faust allows you to do that. Yes?
Is the idea that the user interface is built with Faust, or Faust builds the background to which you can apply any user?
That's a good question. Well, we'll see. I'll kind of answer this question throughout the workshop because it's kind of hard to answer it just at once. But you can build user interface in Faust. So you can build user interface, but there are simple user interfaces.
But the API is such that you could build other ones as well, or does it?
Well, the advantage is that it's going to look prettier if you do it by hand. Like Faust will build user interfaces where you're going to have like knobs, sliders, groups, drop-down menus, or just like simple user interface elements. If you want to build an interface where I don't know, it's like a guitar distortion, and you want like a fancy wood panel with like metal screws, and that kind of things that you can't do in Faust because that's something you basically have to do.
API such that you could.
Oh yeah, you can totally do it. Yeah, absolutely. Yeah. Okay. Any other question? Good. Okay. So you should all have installed Faust Live on your computer. That's not what we're going to use yet. Faust originally is a command line tool. Okay. Then a lot of things developed around it, and Faust Live makes things much easier for developers. But originally, Faust is a command line tool. So it means that it's something that you use in a terminal. So that's my terminal. So Faust is just used there, by calling the command Faust in here. And if I press return, well, it tells me that there is no input file. It's normal because I didn't really give Faust anything to work with. So I'm gonna. I'll explain those things for those of you who never used a terminal before, but here I'm just going to go in a directory on my computer, which is called Faust Workshop. And this directory is basically this folder here, okay? And this folder has a simple Faust code that I can open just in a regular text editor. I'm not going to tell you what it does here for now. It's just to show you what Faust does. So this is a simple Faust code. Okay. Now if I go in the terminal and if I say Faust, okay, so Faust, and then the name of this folder, which is d1.dsp. .dsp is the extension that we use to call Faust programs. So if I say Faust d1.dsp, and if I run that, then I get a lot of things. So this thing here that was displayed in the terminal is basically a C++ code. So what Faust does in its most simple use is that it generates a C++ code based on something written in Faust. Okay. So I can save this C++ code in a file. I could do it in different ways, but if I want to save that in a C++ file, I can just say Faust, the name of the file, then -o for output, okay? And then just create a new file that I'm going to call d1.cpp for C++, okay? So if I run this command here, now I don't have things displayed in the terminal anymore. However, if I go in my browser here, I can see that I have a C++ file that was created. If I open this C++ file, I can look at the C++ code that was generated by Faust.
That's essentially all that Faust does. It generates a C++ file. Yeah.
That's like,
It tracks a lot of the...
yeah, it does way more than that, but originally, like, that's what it does. Like, fundamentally, that's what it does. It can also generate Java, JavaScript, LLVM bytecode, C, and that's probably it. So LLVM is very convenient because so Faust Slide that we're going to use after that never compiles anything to C++. It goes straight from Faust to binary through LLVM. And that's very convenient because it's extremely fast, because you don't have C++ compilation happening. So it's almost instantaneous. And it's very convenient because it also allows you to embed the Faust compiler into pretty much anything. So we have an embedded version that works on Android. We have an embedded version that works in a web browser, etc. And all that works with LLVM. So yeah. OK, so back to the fundamentals. So Faust generates C++ code. Okay. Another thing that Faust does, so if I just run that, then I can take this C++ file and put it into any project that I want. Like, let's say that I want to make an iOS app, for example. I can just take this C++ code here, put it in my app project, and call it to do the DSP, the DSP basically. And, we're not going to look at we might look at it later during the workshop, but we're not going to look at the C++ code generated by Faust right now because I don't think it's very good for you to do that right away. So that's the first thing that it does. Then the other thing that Faust does is that it has a set of what we call architecture files that are part of the Faust compiler and that are basically wrapper files that go around the generated C++ code to turn it into something else. So that's how we can go from Faust to SuperCollider, Faust to Chuck, Faust to CSound, Faust to MaximSP, PD, or many, many other things. So those template files just basically go around the C++ code generated by Faust and turn it into something else. So you should have the Faust distribution installed on your computer if you read the emails that I sent you. And you should also have the source code of Faust because I think I said that you should keep it on your computer. So if I go in the source code of Faust, which is here, so you should have that somewhere on your computer. Do you? Or, well, if you don't, download it, and that's, yeah. So there are a bunch of things here. But what we're going to look at now is architecture. So this folder here contains all the C++ file that will turn the C++ code generated by Faust into one of these things. So if I open this folder, I got a lot of things. But that's just showing that to you, so that you know where it is. We're not going to look at that into details, but that's where they are. Okay. So if I go back to the terminal, and if I say Faust-A, A stands for architecture. So now if I choose one of these architecture files, so let's say that I want to generate the source code for, let's say, a max, wait, which one would be good? Okay, I want to generate the source code for a LV2 plugin, for example. Okay, I have lv2.cpp here. if I say lv2.cpp after this flag here, which is for architecture, and if I run this command, it still works, except that now if I look at the C++ code generated by the Faust compiler, it's much bigger, and it has it basically turns the C++ code generated by Faust into an LV2 plugin. So if I compile this file with the C++ compiler, it will generate a MaxMSP external. Okay, so all these things I'm showing to you, that's like the low-level part of what we're doing. It's very easy to do. Like right now, it might look very scary and very complicated, but all these things are very well automatized. I'm just showing that to you so that you know that it exists, basically. Okay.
What library and include paths you need to compile the CPP?
The what? Sorry.
What library and include paths do you need for the CPP?
That's a very, very, very good question. So Faust itself, the C++ code generated by Faust doesn't have any dependency. It only uses standard libraries and doesn't require any includes or anything like that. However, all the architecture files used by Faust are going to have dependencies, right? So let's say that if you want to compile a MaxMSP external on your computer, you're going to have to install the MaxMSP SDK on your computer if you want to do it. Otherwise, it will not work, and you're going to have errors that will be thrown. So every time you want to use a new architecture in Faust, you have to install the dependencies for this specific architecture. However, Faust itself doesn't have any dependencies. So yeah.
Is there a minimum level of C, like C++ 11 or earlier? Or?
No, it doesn't really.
Generic, you don't even care about that.
Yeah, you shouldn't care too. The thing is, we're trying to keep everything up to date. So in general, things are tested all the time with the most recent version of the C++ compiler. So. Plus, I mean, it only makes sense because like all the plugins technologies and all these things, they get outdated very, very, very quickly.
C++ is advancing like crazy. Right?
Oh yeah, I know. And so we just assume that people have like the most recent version of the C++ compiler on their system. Okay. So if you installed Faust properly on your computer, in addition to the Faust program install, you should have also a bunch of other things that come with Faust. So if you say Faust 2, okay, and then you press the tab button on your keyboard, then your terminal should show you all the programs that are installed on your computer, and that starts with Faust 2. Okay. So Faust 2 tab. Okay. So all these things are softwares and programs that you can use to turn a Faust code into something. Okay. So there are actually a little bit more than that, but those are like the main one, and you shouldn't have to use others. So is it big enough? Like, can you see things well in the back? Yeah, that's perfect. Cool. So I'm just going to go over all these things, and just quickly see what we can do. But so Faust to ALQT stands for alsa Qt. So it means that if I give a Faust code to this program here, I will get a standalone application with a Qt interface. Qt is a library that you can use to create user interfaces with an alsa audio engine. So it's only for Linux. And as most of you have Macs in the room or Windows computers, you will never have to use that. Faust to alsa will create an alsa application with a GDK interface. Faust to alsa console will create an application with an alsa audio engine, but it's an application that you can run in your terminal. So it doesn't have a user interface, but you set the parameters using the terminal. Faust to Android will generate an Android application that you can install on your Android tablet, Android phone, or anything like that. That's actually one of the beauty of Android. It's open enough so that you can do that. You probably saw, if you read the list, that we also have Faust to iOS. So Faust to iOS works fine. The problem is that the application that is generated by Faust, if you want to install it on your iPhone or your iPad or anything like that, you're going to need an Apple developer account for it that you have to pay $100 for every year. On Android, it's not the case. Like the app generated by Android, you can just like drag and drop it on your tablet and it will be installed, which is very nice. Faust to API, I'm going to skip that. Faust to ASM and Faust to ASM.js. So those are JavaScript things. So that will generate JavaScript code that you can run in your web browser, and that will just make sound in your web browser. We'll look at that a little bit closer later during the workshop. Faust to AU will generate audio unit plugins. So it's only on the Mac. We'll use that later also during the workshop to make plugins for GarageBand or Logic. AU Synth will generate an audio unit synthesizer. AU is only for effects. CAQT, that one is interesting for Mac users because it's core audio with Qt interface. So if you run this script here, you will generate an application that you can run on your Mac, and that has a Qt interface, and that directly connects to Core Audio, which is the main audio engine on the Mac. So if you want to run that, you'll have to have the Qt library installed on your computer. Otherwise, it's not going to work. Qt can be a little bit long to install, and it's also very big. It's like 3 gigs of space required on your disk or something like that. So it's takes up a lot of space. But that one is very nice. Faust to Chuck. So you generate a chuggin. Faust to C-Sound, you generate a C-Sound opcode. Very convenient. Faust to DSSI, Faust to EPS. I'm skipping those because they are less interesting. Faust to Firefox. I'm going to skip that too. Faust to GraphView. Or Faust to iOS. Faust to iOS generates a fully working iOS application. It's nice, but once again, if you want to install it on your iPad, you're going to need an Apple developer account, and you have to pay for that. Faust to Jack will generate a Jack application with a GDK interface. That one works both on Linux and on the Mac. Very convenient. Jack console. Jack application that runs as a command line application. Okay, I'm going to skip that. Jack with a Qt interface. Java Swing. So it's a Java application with a Swing interface. Yes?
What's Qt? Is it QuickTime?
No. Qt is it's a library to build user interfaces. It's like Swing or GDK, or it's developed by Nokia, and it's open source. So yeah, and it's it's literally spelled like that, Qt. Yeah. LATSPA are plugins on Linux. LV2s are also plugins on Linux. So I don't think you guys are going to have to use that. Faust to MathDoc. So that one is kind of funny. That one generates a PDF with a mathematical documentation of your DSP code. It's interesting. It works fine if your algorithm is not too complicated. If it's a complicated algorithm, it's going to generate like 80 pages of transfer functions, and that's just impossible to read. So it's a research project that we had 5 years ago where we were trying to find a good way to document electronic music pieces, basically. So that would have a tool to automatically generate a documentation of the patches and of the algorithm used by the composer. But I mean, it's interesting. It's but it's a nightmare. So yeah. Max MSP6. So that one will generate a Max MSP external. on MaxMSP, we have this thing called Faust Gen. So it's like Gen on MaxMSP, except that instead of using the Gen programming language, you use Faust. And it's nice because it compiles in real time using LLVM. So every time you change your code, the MaxMSP external will be updated automatically. So that's nice. Oh, that should work. Yeah, I think that it should work. Yeah. The thing is, so you realize that all these things it's a lot of maintenance because there are a lot of things to maintain all the time. There are only 3 developers. So some of these things here just sometimes stop working, you know, and when they stop working, you should send us an email so that we make them work again, you know. But it's just very hard to maintain Faust because it has so many things that gravitate around it, and that's the problem. NetJack, Octave. That one is nice, and we'll look at it in more details later during the workshop. Octave is an open source version of MATLAB, basically. But Faust can generate MATLAB scripts and also Octave scripts. It's very convenient to debug your algorithm. So let's say that you wrote an algorithm in Faust, you know, and you want to plot the waveform, or you want to do an FFT on the waveform to see what's in the waveform. You can do that very easily because Faust can generate MATLAB script of the output of your Faust object. So we'll look at that later. Faust to OWL. So that one is funny too. I don't know if you know about the OWL, but this thing was. It's a stomp box, a programmable stomp box. It was a Kickstarter project from 2 years ago done by some British guys, I think. And so that generates plugins for this stomp box. But the thing is, I'm not sure if it actually, I think they got the money for it, but on Kickstarter, but I'm not sure if they released it or anything like that. Well, I haven't heard from them for a while, so I don't know.
I've been meaning to order one.
Yeah.
So I'm not sure if they actually exist.
Yeah, I don't think they exist anymore. Yeah, it's well, I don't know. Well, it works if you haven't all. So yeah, PAQT, Poor Audio Qt. So Poor Audio application with Qt interface. Faust to PDF. That one, I'm not really sure what it does, but apparently generates a PDF of something. Faust to Plot. That one will generate the MATLAB script. Very useful. We'll look at that later during the workshop. Faust to PNG. That one is very nice and very important, and it kind of goes along with Faust to SVG. Those generate a graph, so a block diagram of the algorithm that you run in Faust. We'll use that a lot during the workshop because it's very useful to be able to see how your algorithm looks like as a block diagram, because it kind of gives you a user interface for it. The thing is, during the workshop, we're probably never going to use those tools because Faust Live does that very, very easily for you. I'm just showing you that so that you know that it exists, you know, and that if you want to go further after the workshop, you know about all these things. So, but we're probably not going to use terminal a lot during the workshop. Faust to pure data. RAQT, I think it's probably real-time audio QT, Faust to ROS. So those are, I'm going to skip them because they are research projects, so not that interesting. RPI, Faust to SC, so that one I'm going to skip it too. Faust to Super Collider, Faust to SVG. So you know SVG is it's vector graphics format. So it's basically a picture of the block diagram. If it's PNG, it's bitmap. If it's SVG, it's vector graphics. So Faust SVG is better than PNG. We'll see why later. We can do VST. We can do. So those are for Windows. It's Windows for Max MSP, Windows for pure data. Yeah, Windows for VST. Yeah, because terminals works in a totally different way on Windows than on Linux and Mac OS X. So they have their own script. And finally, Faust to web audio and Faust to web audio, but with an ASM.js background. So yeah. Whew. All right. Any questions so far? I mean, like, I'm just like throwing these things at you for now, you know, and just you know, just try to take as much as you can. But once again, like, it's might look scary for some of you for now, but it's going to be fine. So yes.
Cross-reference for the SDKs you have to have. You have to get from Steinberg, I guess, for VST.
Sure, sure. Well, so a very important resource that comes with Faust is the Faust documentation. So if you go in the Faust source code, which is here, and if you go in the documentation folder, there are a bunch of stuff. Many of them they should just get out of here because they are totally useless, but that one is not useless. Faust quick reference. So that's the thing that you want to look at a lot. It should tell you everything that you need to know. So that's, yeah, you should check that out. The main tool we're going to use during the workshop is Faust Live, that you should all have installed on your computer. Historically speaking, there was a previous version of a Faust IDE, which was called Faust Works. If you go on the Faust SourceForge project, that's probably like one of the default things that you can download. Faust Works is old. It still works, but you don't want to use it. So don't try to use Faust Works. I know that some of you sent me emails about using Faust Works, and I told them, no, don't use Faust Works. Faust Live is better, and that's what we're going to use during the workshop. Okay, so Faust Live. So Faust Live on Mac OS X should run without Jack. It should be able to connect directly to core audio. However, in the frame of the workshop, I really recommend you to use Jack. And you should have installed Jack on your computer if you followed the instructions for installing Faust Live properly. So what is Jack? I'm sure many of you already know what Jack is, but I'm just going to remind you quickly what Jack does. So Jack is this software that connects to your audio interface on your computer. So on the Mac, it will connect to core audio. Okay, so it goes at the top of that. And it looks like that. And then what Jack allows you is to connect the inputs and the outputs of the different applications on your computer that are using audio together. So let's say that you have Google Chrome and you want to connect it to Faust Live, for example. You can do it with Jack. So it's very useful. So if I start Faust Live, well, I'm using Linux, so it's probably different for you, but you know, just start Faust Live. When you start Faust Live, the first thing that shows up is this window. So you have examples. You have the possibility to create a new default window. What we're going to do here, we're just going to use one of the example. And we're going to use the harp automation example. Okay. So if I open the harp automation example, I get this. And if I go in Jack, I see that in Jack I have FLW1, so it's Faust Slide window 1. Every time I want to create a new window, I can run like different objects in Faust Slide at the same time, and they will all appear as a new software in the Jack window. Okay, so if I expand Faust Slide window 1, I see that Faust Slide has 2 outputs. Okay, it's because this Faust object here has 2 outputs. It can have as many outputs and inputs as you want. Okay, so if I want to hear the sound of this thing, I just connect Faust Slide 1 to my audio system, and I should hear sound.
Sorry, did anybody else have trouble finding the Jack window on the Mac?
Yeah, I have Jack Pilot.
So that's, yeah, very good question. So Jack on the Mac comes with different versions. And Jack Pilot looks different than that. Do you have Jack Pilot or?
Yeah.
So in Jack Pilot, so, oh, it's not working?
No, it is, but there's another binary, also KQJA.
Yeah, QJack is the one that looks like that, basically. Both of them should work. Jack Pilot has a more simple user interface. And in Jack Pilot, if you want to connect things together, you have to choose one object and double-click on the other side if you want to connect them together. But it doesn't draw the connections directly in it. So, yeah. Any other question?
How do you get the hard button issue to appear in the Jack Pilot? Is that,
It should appear automatically. So Faust Slide is an on-the-fly compiler. So here we used an example, okay? But if I create a new Faust Slide window just by doing Control-N or just by saying File, New Default Window, okay? See that every time I create a new window, a new Faust Slide window is created in Jack, okay? So for now, I'm just going to use that one. Here it tells you drop your Faust file. So if I have a Faust file on my computer, so for now, you shouldn't have one, but it's just to show you that you can do that. If I take the Faust file from earlier, which is here, d1.dsp, and if I drag and drop it in here, boom, it was compiled. Okay. So that's very convenient. Now, every time I will make a change in this Faust file in a text editor, the change will be reflected in Faust Slide. So Faust Slide always keep track of changes in the Faust file that you're using. Okay, we'll look at that in more details afterwards. So sorry. For now, let's just stick to the harp example. So this thing here is a simple Faust code that was compiled into an application. Yeah. So it has sliders that control parameters. So Faust Slide is very convenient because it basically allows you to see in real time what your Faust code looks like, as an application. So we're going to use that extensively during the workshop. Another thing that Faust Slide can do is that it can display the SVG diagram of your Faust code. So if I click on View SVG diagram here, it should open the SVG diagram of the Faust code in your web browser. As long as you followed the instructions during the installation of Faust Slide properly, and you said that you wanted to open SVG diagrams directly in your web browser. Okay. So this thing here is the block diagram of my Faust app. It is an interactive block diagram. So if I click on objects, I open new objects. Okay. If I click on that, I will open a new object. If I want to go back in time, I can just say go back. But I can also click on the side here, and that will take me back to the upper level. Okay, so these boxes contains elements. Okay, so it's a tree. You can open, you know, and you can go down. I'm not giving more details about that for now. We'll see that later during the workshop. Okay, so FAL Slide can show you the block diagram of your Faust code. It can also show you the interface of your Faust code, and you can play the sound of your Faust code in it, which is very convenient. Okay. Yep.
Window. There's an option in window.
Oh, how do you? Oh, sorry. Yeah, you say window, view, SVG diagram. Yeah, you should make sure that the default program to open SVG files on your computer is Firefox or Google Chrome. Because you want to open the block diagram in your web browser, because if you open it in something else, you're probably not going to have the interactivity that you have here, where you can like click on one box and so just go like in the preferences to open specific files, and that should do it. Another very, very, very convenient tool is that. And that's going to make your life very easy. It's export as. So if you're connected, so don't try to export anything, because well, I'll tell you why not to do it for now. But so export as is this very practical tool where Faust Slide connects to a server and allows you to compile that into all the things that we saw before without having everything installed on your computer. So it does the compilation distantly and then returns you the compile object. So you can choose the platform like OS X, Linux, Android, Web, or Windows. So let's say that I want to create an Mac OS X Max MSP external. Don't click on export. I'm going to do it, but don't do it. I'm telling you why. It's because our server is very small, and I'm scared that if you all do it at the same time, it's going to crash. And it's in France too. So it's far away, you know. So you can try to do it during the workshop, but I think it's a very bad idea if we all click on the export button at the same time. It never crashed before, so it should be fine. But yeah, if I do export, then it connects to the server, compile the object, and eventually, at some point, here we go. Compile it, so now if I save that, it gives me a zip file that contains a Max MSP external. So if I save it in my downloads folder, and if I open my downloads folder here, I have a zip file, and the zip file contains a .mxo object, which is a Max MSP external.
So it means you don't have to download the SDK for Max.
No, exactly. Yeah, with this tool, you don't have to worry about all these things. It does it distantly, you know, and it works. So the only issue with that is that with some obscure versions of Linux, for example, it might not work, because the compilation for Linux, for example, is done on a 64-bit machine that runs Ubuntu, you know, and for some architectures, you might want to compile that on your own computer, basically. But for Mac and Windows, in theory, it shouldn't be a problem. So you got pretty much all the Faust architectures here that are available. So if you go on OS X, you can see you can do Core Audio, C-Sound, Jack, Max MSP, pretty much all of them. One small detail though. For Core Audio or Jack, Qt, if you try to export those, it might not work. It's actually not. It will not work on your computer if the Qt SDK is not installed. Why? Because in those applications, the Qt SDK is called as a shared library. And the reason why we do that is because Qt is huge. And if we were embedding Qt in the generated app, the app will be huge. It will be way too big to do that like with an online compiler, and because it will return you a file of like 200 megabytes or something like that. And while here it will return you a file of like 500K basically. So it's better. But that's pretty much the only exception. All the other architectures should work. On Linux, you should have all of them too. Some of them are only in 64 bits because, well, 32 bits is less and less supported on some versions of Linux, so it's a little bit hard to compile it. If you go on Android, if I compile that, I will get an Android application, and I can just like install the Android application on my smartphone or my Android tablet, as long as I have a very recent version of Android. If you have a version of Android that is before 4.2, there are very good chances that it's not going to work. The other problem on Android is that the audio latency is not very good, or it depends on the device that you have. Like on a Nexus 7, for example, it's terrible. On a Nexus 9, it's decent. And by decent, I mean 35 milliseconds, which is a lot still. Because on iOS, it's more like in the range of 10 milliseconds. And when I say terrible on the Nexus 7, it's in the range of 150 milliseconds. And then it's really, really bad because, 150 milliseconds of latency means that, if I press a button here, it's going to take 150 milliseconds before it makes sound. And that's a lot. Even though it doesn't sound like a lot, it is actually a lot. So it's totally perceptible and not very good. But I know the guys at Android are working very hard at solving this problem. And I met with them 3 weeks ago, and I know they are working on it. But it's very complicated because there are so many different devices, and I know it's kind of hard to. It's kind of hard. Oh yeah, I think the trick is that you need to use a specific sampling rate and a specific buffer length for the kind of device that you use. And if you use the recommended buffer length and the recommended sampling rate, then it's okay. But I think the best that they got is 35 milliseconds though.
It's getting much better than it deserves. So.
And yeah, that's what they said. So yeah, well, there is hope. One day it will be better. Yes, web. Web. That one is pretty cool. So you can generate ASM.js or web audio ASM.js objects. If you export that, it will just return you an HTML file. You can open this HTML file in your web browser. And it should make sound in the web browser based on the Faust code that you wrote, which is really, really cool. I'm not going to do it here because Jack and Fire and Google Chrome are not very good friends on Linux. But on your computer, it should work. One small detail, though. It might not work in all web browsers. Why? Because all these technologies are very, very experimental. And ASM.js is very well supported on Firefox. It's OK on Safari, but on Google Chrome, it's a little bit more complicated. Why is it using ASM.js instead of plain JavaScript? Well, there is a very good reason for that. It's just that ASM.js is way more optimized than JavaScript for real-time audio signal processing because it has types, which is not the case of plain JavaScript. And I'm not going to go into details, but you should try that. It's pretty cool, and in theory, it works well. Any questions so far? No? Yes?
You did demonstrate Windows.
Oh, Windows. Oh, Windows. Yes, sorry. Well, on Windows, MaximSP, 64 bits, pure data polyphonic objects, VST and VST instruments. Yes.
So basically, we can do exactly the same thing with Faust 2.
Absolutely. Yeah.
So does it do the same thing like send the
No. So that's a good question. So if you run the Faust 2 scripts on your computer, then the compilation, the object will be made on your computer. If you run that, the object will not be made on your computer. It will be made on a server somewhere in France. And so this tool here is good as long as you don't have to make a lot of things, you know, and it's good for prototyping, basically. I mean, if you're like, okay, today I want to make a VST plugin for Windows, I've never done it before, you can try to do it with that, you know, but if you know that you're going to make VST plugins on Windows all the time, it's probably better to install the SDK on your computer to be able to compile VST plugins on Windows. So if I do it in the terminal, it does it locally. If I do it in Faust Slide, it does it on a server distantly. Yeah. Cool. Okay. You have a window here for options. So you can choose options of compilation. I'm not going to go into too many details, but these object here takes OSC messages, so you can control that with OSC if you want. OSC is open sound control. It's like, for those of you who don't know what it is, well, you can Google it. I'm not going to explain to you, but OSC is it's like MIDI, but you can do more, basically. It's more than that, but just check it out. MIDI should work too. So if you plug a MIDI keyboard on your computer and you try to control an object in Faust Slide with your MIDI keyboard, it should work. However, your Faust code will have to respect specific standards that we'll see later during the workshop.
So where's the option?
Here. You got like window options, and if you click on it. And you can configure the OSC port. And yeah. Another thing that you can do, and that one is pretty cool too, you can view the QR code. Why? Well, if you view the QR code, you get a QR code, okay? And then if I take my Android tablet, and if I always get very confused about where, there we go. So if I take my Android tablet, okay, and my Android tablet is connected to the CCRMA network, has to be connected on the same network than my computer. But if I scan the QR code, okay, if I open that on my Android tablet, ta-dam, I got Faust Slide on my Android tablet, okay? And so now if I do that, that's it. So that I mean, you see that the QR code is just a link to the IP address of my computer on this network and to a specific port on my computer. So if you open this URL in your web browser on your computer here, you should be able to control the Faust Slide on your computer, basically. That's very convenient if you want to make art installations, for example, because then you can run Faust code on a computer or like a Raspberry Pi or anything like that, you know, and then you can have people connect to the little server running on the computer and have people control different parameters of the Faust object with. Yeah. Okay.
What happens when multiple people try to control in a different way simultaneously?
Well, I think it's like it just receives messages, you know. Yeah. So like it will process the last messages it received, basically. So so it can probably become very chaotic, but yeah.
It's emitting us.
What?
It's emitting us protocol and the server's responding.
Yeah. There we go. So the other thing, for those of you who are trying it, you probably saw that there is drop your DSP file here at the top of the interface on the tablet or on the computer. If you drag and drop a DSP file in this zone here, it will replace the Faust code running on my computer by the one you drag and dropped on your computer. So it's very good for collaboration. So it means that you can work with someone else or several people in the same room on a specific Faust code, and then anyone can drag and drop a Faust file in the web browser and have it run on the computer that runs the object, basically, which is very convenient. Okay? Any questions? So this works in Faust Slide, but it also works in some Faust architectures. So for example, if you create a core audio Qt application on your computer, and you tell the Faust compiler that you want to have the HTTP server running in the application that you're creating, that will be embedded in the application. So if you run the application outside of Faust Slide, anyone will be able to connect to your computer as long as you're connected on the same server and control that. So you don't have to run Faust live if you want to do that kind of things. Okay, good. So the last thing before we actually start making things, I want to show you is I'm going to go back to the terminal. Okay. If you want to run Faust in the terminal, Faust has a lot of options. Okay. So if I say Faust.-h, okay, if I run that, it will give me a list of options that I can run with the Faust compiler. So for instance, I'm not going to describe all of them because many of them are very weird and obscure, but the useful one are, well, see, you can actually generate the SVG diagram directly in that's part of the compiler, so you don't have to use the script if you want to. You can just use that as an option. Same thing for the mathematical documentation. No, I'm just skipping. You can generate a JSON description of the interface of your Faust object. It's very, very convenient if you want to build systems that use the Faust compiler and that generates the user interface at the top of it. Because you can get a JSON description of the interface, and that's very good. Same thing with XML. XML is also a description of the interface, but in XML format. Okay, I'm just... well, we saw that one. -a is to integrate the architecture file. Inline is pretty useful. Instead of calling some of the libraries that are part of the Faust compiler, it will embed them in the generated C++ file. It's going to be very ugly if you do that, because you're going to end up with a C++ file that is going to be like 5,000 lines long and with a lot of shit in it, basically. But it might be very convenient for some people to do that. You can change well, I'm skipping that because that's those things are. You can set a timeout because sometimes when you work on giant algorithms, the Faust compiler is always going to try to further simplify the generated C++ code. You can set a timeout so that the Faust compiler stops trying to simplify things at some point. By the way, the C++ code generated by Faust is very optimized. Most of the time it's more optimized than if it was handwritten by a human, because it knows all the tricks of C++ to do like small optimization. So in Faust, when you code in Faust, you don't have to worry about using multiplications instead of divisions or that kind of stuff, like the Faust compiler does that kind of optimizations for you. So you don't have to worry about like old school DSP stuff. Okay, vec, very, very useful. It will vectorize the C++ code. So for those of you who knows what it means, because I don't want to spend too much time doing that, but what it's going to do is that it's going to allow you to run different parts of the algorithm generated by Faust on different cores of your computer. So if you don't use this this option here, your entire algorithm will be run on the same core of the processor of your computer. Okay. Which is fine in most cases, because it's going to be very rare when you have to run algorithms that takes up more than one core, because I mean, like, a core is already very powerful. However, if you work with like iOS, for example, or that kind of things, iOS, especially like the iPad, has like a lot of cores, and each core is not very powerful. In that case, it's very useful to vectorize the C++ code, because then you spread the load on the different cores of the processor, and it's yeah. Anyway, those are CS details. We're never going to have to do that in the frame of the workshop. I'm just telling you so that you know that it exists. OMP is also vectorizing things, but using OpenMP. So it's probably going to be more optimized if you use OpenMP. Okay. You can tell the Faust compiler to instead of using floats, you can use doubles, so you can change the type of the variables that you're using to store the different samples, which in some cases might be useful, although it's probably going to be very rare when you have to do that. Yeah, and that's pretty much everything. So one last thing, and after that we're going to do more simple things. One last thing is that the version of Faust that I'm running on this computer is Faust 1. If you go on the Faust SourceForge webpage, and you probably already all did that. If you go on the Faust SourceForge webpage, in the Git repository, you probably noticed that there is Faust and Faust 2. So those are two different versions of Faust. In the frame of the workshop, we're only going to use Faust. Faust 2 is like the experimental branch of Faust. And the reason why it's experimental is because this version supports multi-rate. Faust 2 supports multi-rate, which is not the case of Faust. What it means is that in Faust, at least this version here, we're not going to be able to do FFTs, we're not going to be able to do convolution, we're not going to be able to do that kind of algorithms, because those algorithms needs multi-rate. If you don't have multi-rate for these algorithms, you're not going to be able to run them in real time. Thing is, Faust 2 is very experimental, so it doesn't work very well. So don't try it. Just telling you that so that you get the global picture. Okay, good. Any questions?
Is there a switch that allows me to tell which version I have installed? The binary?
The only way to do it is to check out the other branch. So if you go in the Git repository, by default, the branch that you're using is the master branch. If you want to use Faust 2, you should say git checkout Faust 2. Then it will switch to the Faust 2 branch. Then you should recompile the compiler and reinstall it. It's the only way to do it. So, but don't try to use Faust 2 for now. Like, just Faust. This version of Faust is perfect for the workshop, and we're not going to have to deal with more complicated things from Faust 2. Okay.